Now, have you ever asked yourself any of these questions before? I've been designing in 3D for years, but why do I always have to create 2D drawings? It seems a little bit counterintuitive that all of our designs are being created in 3D in SolidWorks, but then we always have to dumb them down to 2D drawings. So I'm going to show you how we can eliminate this tedious 2D drawing process today. Have you ever asked yourself why we don't communicate PMI or product manufacturing information directly in 3D? So again, another question that companies may ask themselves: why are we relying on old technologies or old 2D drawings? And then this is a pretty common one as well between engineering and manufacturing. A 2D drawing is a very poor medium to communicate information, and there tends to be a lot of clarification and generation of additional documentation in order to communicate what is happening. So if these are questions that you've often asked yourself, stay tuned. I'm going to have some answers to them shortly. Now, when we talk about defining PMI or product manufacturing information directly in 3D, this is ultimately what we're talking about. We're talking about capturing dimensional information, geometric tolerancing, all sorts of information. It could be notes, and I'm going to show you some examples here. We'll go through a demonstration on how this is done as well. But ultimately, it takes time to create 2D drawings. So I'm going to show you methods that we can speed this information up and actually produce this information all in 3D directly off the model, as opposed to having to create those 2D drawings. Here's a nice little image of communicating on an iPad. Obviously, we can output information created in SolidWorks MBD, and we can output that in a couple of different formats, one being PDF format, the other being an e-drawing format, and I'll show you both of those methods as well. But ultimately, whether you decide, and I'm going to talk a little bit more about drawingless versus paperless at the end of the presentation, but MBD doesn't force you to go out and buy iPads for the shop floor. If you want to print drawings, we can still print drawings. But ultimately, you've got a nice model, however you want to communicate that, whether it's through an iPad or whether it's printing the PDFs, you can communicate that information easily as well. And I'll talk a little bit more about that as well. MBD really is about modernizing your product information. So rather than have 2D drawing that is somewhat dumb, we can have intelligent 3D annotations on the model. And what you see there in that picture is an annotation that is not only existing in 3D, but when I click on that annotation, it actually highlights the feature that we're referring to. So again, that's a big benefit. Sometimes it's hard to tell whether a dimension is going from one face to another face, or what's happening there, or maybe there's overlapping faces. We have intelligent annotations and 3D annotations that really highlight that information as well. The 3D views that we'll create are very structured and very organized. So if I'm looking at a front view versus a right view, I want to see only information that's pertinent to that view. Just like we would traditionally see in a 2D drawing, this isn't a whole lot different in terms of the way we present things and the way we organize and structure our 3D views inside of SolidWorks MBD. And then we'll get into, today in the session, we're going to get into the templates and how those look and how the templates can be customized for the 3D PDF. So you can see the Javelin logo in there. You can put any amount of information that you want inside of the templates, and those can be customized. There's a very nice intuitive UI for your template customization. So let's get into a product demonstration here. I'm going to move over to SolidWorks. And actually, before I go over to SolidWorks and start looking at this information, I'm going to show you a couple of outputs from this particular gear assembly. Now, this is a camera housing underwater camera housing, and it's got some gears and a bunch of other things, and there's a mount inside of there as well. Now, when I look at the output that's here, I'm just going to pull up the 3D PDFs for this particular design. You can see here that the 3D views that I've captured are available to me inside of the 3D PDF. And this 3D PDF not only is a static PDF, but I can, zoom in and rotate, and I can manipulate around. So how would I capture this information? Well, these are just 3D views that are captured in MBD. If there's critical information and critical measurements that we need to capture, we can capture that information as well. We can also capture exploded views inside of the 3D PDF as well. So we're not limited to just certain views. We can capture all of that information. One of the other things that you'll notice here as well is the interactive bill of material that's in here as well. So we can capture that type of information as well. Again, just giving you an idea on what the final output may look like for files that are generated in MBD. So let's flip back to SolidWorks here. As you can see from the gear assembly here, what I have is this underwater camera housing, and there's a couple of things that need to happen in here. Obviously, the gears need to mesh properly, and there's some information that's happening in here. But I've got a couple of different section views. So upon having MBD available, there's a tab down here at the bottom called 3D views, and this allows me to capture any 3D views that I want. Think of them as really drawing views that I'm capturing. Other than I'm not capturing them in the drawing, I'm actually capturing them in the 3D view. Now, when we take a look at the views that are captured here, I have a section view. I also have a section view in here, really communicating how this bolt information goes together. So I've got a couple of bolts here that are mounting it to the lower plate. So again, there's some information that's being communicated that way as well. Let's hone in on the particular part of interest here. This is the gear plate, and in this particular instance here, this part needs to be machined to some very tight tolerances. Now, if you carefully consider the geometric dimensioning and tolerancing, it'll actually lower your costs in some case. So it could ultimately be applied to any part, and I'll show you how we could apply that information inside of here as well. But ultimately, what I have is I've got a couple of 3D views in here. This isometric view has all of our dimensional information in here, and then I've got a couple of other things that are happening as well. Generic notes can also be inserted into the notes area inside of SolidWorks MBD, and these notes don't have to be dumb notes. They can actually be intelligent notes as well. And what I have here, if you look at the very top, I have the material that's defined, and this is actually linked to a note inside of the part. So if I go and make a material change, let's say a 6061 T6, and move that and change that to just a plain 6061 alloy, that material change is also going to reflect and update in the 3D note and the 3D note view that's inside of my 3D view. Now, some of the other things as well, as I go in and capture these different views, the different views are showing different information depending upon that particular view. One of the other things that is really nice about MBD, as I start looking at various bits and pieces of information, again, you can clearly see how this dimensional information is showing up. And furthermore, when I look at the PDF that's generated of this particular gear plate in here, there's some important things that are actually happening inside of the gear plate as well. So when I start looking at these measurements here, these measurements again very clearly communicate exactly what's happening inside of this particular part. One of the other things that you'll notice is the actual face highlighting for dimensions as well. So If you want information to actually highlight on there, notice when I click on this dimension, very clearly it's illustrated what face that is referring to. So you can see the face that is highlighting on there. You just don't get that with a 2D drawing, a traditional 2D drawing, the ability to be able to see, okay, this is actually going from the bottom face that's highlighted in red to the top face that's highlighted over here. So again, any dimensions that I click on have dynamic highlighting automatically associated and built into that as well. So there's just a smattering of information and stuff that could be captured in here. This could be anything from dim expert annotations. So the annotations showing up in pink are dim expert annotations. On this particular left view here, these are just some reference dimensions that I've added inside of here. And there could be all sorts of information that's captured in here, as well as configuration or different version information on here as well. So this particular example here is capturing two different variants in a particular version or a particular configuration. So let's take a look at how you would actually generate this information and how this would all start. So let me flip over to another model here. This doesn't have any information in here. Now, one thing to keep in mind here is that the information that you use to design isn't always going to be the information that we use to manufacture. And what I would recommend for most users, dim expert is something that we added back in SOLIDWORKS 2007. And dim expert has the ability to really take a look at the part and come up with the dimensional information, the tolerance information for this particular part for manufacturing. And there is some settings for this. If I go into my options here, and underneath document properties, you can see dim expert. There is some setup that's involved depending upon the tolerancing and everything that is that you will want to use. So depending upon which tolerance you want to use, as well as the information, again, that can be all set up in our document properties as well. So once that's all set up, I'm going to slip over to my dim expert manager, but also on our SOLIDWORKS MBD task pane or ribbon bar, we have the ability to start adding all sorts of information on here. So I'm just going to pick up an auto dimensioning scheme. This is automatically going to recognize tolerancing features and assign them based off of based off the tolerances that are specified in my design. So we'll pick up an auto dimensioning scheme. At this point in time, all we really need to do is set up some settings, and we have to tell what type of tolerancing we're going to be using. Is it plus, minus, or geometric tolerancing? And then simply just pick my datum. So my primary datum for this particular part is going to be this face. My secondary datum is going to be this face, and my tertiary datum is going to be this face. And that's ultimately all that we need to pick. Now in this particular instance here, if we want to filter the features that we're going to be defining, I can simplify that information. But ultimately, I hit OK, and it's going to define all of my information, all my geometric tolerancing automatically for me. Now, what you see here in the feature manager tree is all the information that has been defined. Now, I can look at this in a slightly different option. I could show that using an annotation-based tree, and what that's going to do is it's going to put the datums at the top, and then it's going to put some of the tolerancing and organize this in a slightly different fashion. Now, as you can see here, this looks a little bit messy because all of the information is being displayed for this entire part. As we go and move and manipulate around, you can see everything here is being shown. So what I want to do now at this point is just go to my 3D view tab down at the bottom, and I want to capture some of these 3D views. Think of these as the views that I would typically do in the drawing, but I'm going to capture them in 3D instead. So the first view that I'm going to capture is going to be my plane isometric view. And I have the options to pick which annotations I'm actually showing. In this case, I'm going to show all the annotations for the isometric view. So there's my first view. The next thing I'm going to do is just move to another view that I want to capture. Now, notice when I move to a front view, it's only showing me information for features that are available inside of the front view. So not everything is available here. If we want to go and move or manipulate this around, I can do this as well. If I decide I want to hide annotations or show annotations, I can do this as well. But ultimately, I've got a good front view here that I want to capture my second 3D view as well. So I'll name this my front view. And in this particular instance, the only annotations that we want showing up are annotations that are available inside of the front view. At any point in time, if I need to cycle back and forth between any of the views, I just simply double click on them below, and I can cycle back and forth between the particular views. Let's take a look at the top view now. And again, you can see different information is being presented on the top view than it is on the front view. So I'm really just setting up the views that are going to be available to me inside of the 3D PDF or inside of my eDrawing. We'll capture this one more time. And this is going to be my top view, and I'm only wanting to show annotations that are available to me inside of the top view. As you can see here, if I had configurations, or display states, I can bring up different configurations that are showing or using different information inside of my design. And then the last one that I'll do is just the right side view that has information about the A datum. And this will be my last view. This will be my left view. And we're done. So all I've done is I've really just communicated in 3D space what the views are that somebody is going to actually see inside of the 3D PDF. Now, if we want to link in text or other notes and different things like that, we can absolutely do that as well. Now, in terms of customization, there is some customization that we can do as well. So if you decide that you want to customize the 3D PDF templates, just launch the 3D PDF template editor. And what that'll do is it'll put you into the template editor and allow you to edit the information. Really, any information in here can be customized. So if you want to show different custom properties as placeholders in the 3D PDF, you can do that as well. If you want certain images in here, you can do that as well. So I've customized one here to have a little bit of a javelin flavor sitting in a slightly different location, but again, you can customize that however you see fit. Down on the bottom, these are going to be the thumbnails for the views. Those are going to appear down at the bottom. And then you could have interactive notes areas where people can actually place notes in the drawing, or as you can see here, the bill of material table area is also available to us as well. So once you've customized your template, it's now time to just pick the views that I want to do, and I have two options down here at the bottom. I can publish to 3D PDF, or I can publish to an eDrawings file. So let's pick the first option in there as well. As you can see at the top, I have the option to pick which template I'm going to use. So depending upon which one you want to use, I'm going to pick the Javelin one that I've customized here. And we now pick the views that I want to include in the 3D PDF. So in this case, I want the isometric front, top, and left. Only those four views are going to be present. And I'm going to, if we need to do any mapping of text fields, we can put in a text field in here as well. We can add any information that we want here. We can also change and remap the custom property fields if you like as well. Okay, so all this information is customizable. Everything that's presented in the 3D PDF is directly linked to your SolidWorks model. Now, when I hit OK and publish my 3D PDF, it's going to go through each of the individual views. It's going to capture them, and it's going to present them inside of the 3D PDF. This is ultimately what we see here. Again, here's my full isometric that has full information captured in here. Again, you can see all the information that is presented in the full isometric view. and then I have my other views as well. I've got my front view. All of these views, even though they are captured, I can still rotate and manipulate and move them around. And again, these are just different views and different information that is presented to me as well. Now let's go back to SolidWorks and just show you the other output medium, which is eDrawings. Again, same thing. It's a simple one push in order to activate the eDrawings publisher. It launches in eDrawings, and you pretty much get the same thing, except it's in eDrawings, and this could be something that you could view obviously on your iPad. You could view in a couple of different areas as well. And I do have a new 3D view tab and 3D view option as well. So again, if I want to move to a front view, I can move to a front view. We just simply activate my 3D view pane, and I can activate all of this information and display it accordingly. So let's do a little bit of a recap on here. So we've looked at capturing and associating information in the actual 3D view, how we can generate information from SolidWorks MBD directly into a 3D PDF or into an eDrawing as well. And then, of course, intelligent views, intelligent information can also be displayed there, whether it's a section view or whether it's a bunch of annotations or datums or geometric tolerancing. All of that information is now intelligently conveyed inside of the 3D model as opposed to inside of a 2D model. And of course, the 3D view is easy to create, very organized, very structured, and completely customizable for you as well. And then I quickly looked at the ability to customize the templates for 3D PDF and how that's done. That's all included. We include some default templates, but of course you can customize them intuitively however you would like as well. Now, some final thoughts before we wrap up here. It's just the whole concept behind drawingless versus paperless. Now, if I want to take any of that information that I just created here today and print out drawings, so one of the misconceptions about MBD is that I'll need to go out and install electronic terminals on the shop floor or buy everybody in manufacturing iPads for the shop floor. So that is not true. So if you want to print out these drawings, you can still print out those drawings, and you can see the output there on the screen of what that would look like. So it's again entirely up to the person manufacturing that. If they deem that they'll need that information, they can print that information out. So that's drawingless, actually getting rid of the 2D drawing, but you can again still print out drawings if you need to. Paperless is going completely electronic, and actually not even allowing people, or not necessarily allowing, but not even printing out your 2D drawings, but going a step further, which is to have something like an iPad or something electronic on the shop floor, or something that people can view and see information from there. So again, just the differences there that I thought I'd highlight between drawingless and paperless and what that is all about. So with that concludes our short webinar on SolidWorks MBD. I just